Hey y'all, welcome to RAR Math. This is my series of videos on interpreting graphs. This is my second example. It talks about Russell's height at 3-year intervals. So we have our height in feet and we have our age in 3-year intervals. It says right away what output goes with the input of 12 for Russell. Well, the input is always on the bottom. This is always your input. Your output is always over here. When you ask someone their height, you don't say, hey, how tall were you when you were 12? Well, no. When you ask someone their height, you don't say, how tall are you and how old are you right now? Because at the end of the day, what we really care about is the person's height. So what output goes with the input of 12? 3 feet. And it says, translate this into a sentence. So when Russell was 12 years old. I make sure to translate what the 12 means. It's 12 years old. He was 3 feet tall. This graph is probably not accurate because not many 12-year-olds are 3 feet tall. 4 would actually have been pretty accurate, but 3 seems a tad bit short. Okay. How many inputs go with the output of 6? What are they? All right, so if we come to 6, we have 1 input, and that 1 input is maybe 20 years old. We don't usually talk about age in decimals, so I'm going to go to the nearest integer. It's not 21 because 21 is just over 6. So you could use 21, you could use 20. I'm going to say 1 input, 20 years old. What is the domain of this data? Okay, so of the data, I'm actually going to talk about the data in general. We don't know how old Russell's going to be. And when we're talking about somebody's age and height, we really should include everything. So the domain of the data really should start at 0. 0 is less than. Age is less than. Now you're saying, well, it ends at 24. I am not going to be the person who defines how old Russell will be when he dies. That's very gruesome. So what I'm going to do is I'm going to use the symbol infinity. This doesn't mean I think Russell's going to live forever. It doesn't mean I think he's going to live to some infinite age. Infinity can be used just to mean unknown. I don't know how old he's going to be. Because I don't have the equal signs, if I were to do this with intervals, I would say 0 to infinity. You don't have to do interval notation, but it is good to recognize that these two items mean the same thing. Now it says, what is the range of the data? I am going to start at the 2 feet. Most babies aren't born at 2 feet, and probably by 3, 2 feet wouldn't be accurate, but I don't know how short Russell was. So I'm going to start at the 3 feet, and I'm going to put the equal sign because he was 3 feet. And then I'm going to use H for height, and then I'm going to say this top height is maybe 6.1. And I am going to assume that 24 is the tallest Russell's ever going to be. You usually do not grow much after that. What interval is this graph increasing? Well, it's increasing from 3 is less than age is less than 24. It's increasing, and with increasing, we always talk about the inputs. It's increasing over the entirety of this. There isn't any plateaus anywhere in this. I could also say 3 to 24. I do the less than without the equal sign because we don't know. We can assume it came down from here, but if we don't know, maybe he had like a weird growth spurt and then shrunk one day. Who knows? It's not likely, and we could suddenly go down here, which actually is pretty likely. So we use this because these points are not considered an increasing or decreasing point. They're just where it ends. It says, where is this graph decreasing? And it says, never. It isn't. On no interval. It probably would one day, probably if you went out further. People shrink when they get older. It's the facts of life. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel. You can like my Facebook page, and I'll see you on the next video. Thanks.